Hey everyone, Mr. Dingler here again for the fourth and what I promised to be the final video of this side scroller tutorial. In this particular video, what I want to do is finish off the moving object and the chasing enemy script. Okay, so what we'll do, we'll focus on the moving object script to start with. And what we want this to be, we want this to be a moving platform or even any kind of moving object. And what it will do is it will move in one direction. When it hits a certain distance, it will turn around and come back the other way. Okay, and when it gets back to its original position, turn around and head back up. And then it will do that until the game ends, basically. Okay, we'll also have the ability for the object to move up and down, or left and right, depending on what we set. Alright, so let's just start with a very simple one, just to get it moving up. Okay, just to start with, which is just a simple translate. Just like we did with the player script, we're going to add in a couple of parameters up the top. The first one is going to be what we all know and love, called speed. And that's going to control how quickly this thing moves. It's going to be a float like always, and I'm going to set the default value to 2. Alright. The next one, the next parameter is going to be called distance. Now this here is how much distance do we want to travel before we turn around and come back the other way. So I'm going to set that again to 2. Now before I go too far, let's quickly have a look at, this actually is going to refer to 2 units in the game. So if we have a look in the editor, I'll click on the player and let's have a look. If I hold control while I move this object, it's going to move it 1 unit at a time. So if I hold control, move him up, that's how far the object will move in 2 units. If I can't, and then it'll turn around and come back the other way, and that's essentially what the default object will do, movement-wise. It'll be smooth, but that's how far it will move. Okay? You can increase that or decrease that as much as you want, but 2 is just a good starting point. We're then going to add a third parameter in there, and this one's going to call direction. This is going to be an integer, because we don't want a fractional part on this one. It's going to be set to 1 by the default. Okay, now let's put a comment on each one of these lines. So, speed is how fast do we move? That's always pretty straightforward. Distance, how far do we move? And direction is exactly how it sounds, okay? Which direction are we going to move? So if we're moving up and down, if it equals 1, we're going to move up, or we're going to move left at a later point. Okay, if it equals -1, we're going to move down or to the right, depending on which one we choose. Okay, we're now going to add in a quick private parameter to keep track of how much distance has passed. So elapsed as a float, set it to 0 to start with. This is extremely similar to what we did over in the player controller script with the super speed counter. Okay, so the super speed counter was based on time, but this elapsed counter is going to be based on how far we've moved, because we need to see if we've moved 2 units to stop and turn around and come back the other way. So first of all, let's get rid of function start. We're not going to need it. All right, well, what we are going to need is to move the object. So move the object with just a simple transform.translate. Okay, where do we want to move to? We want to move up initially. So let's go just a simple vector3.up times the speed that we want to move at. Now we're actually going to add a little bit more in there. We're going to times this by time.delta time. And the reason that we do this is because if you've got a very weak computer, okay, an extremely powerful computer, without it, your weak computer would move slowly and your supercomputer would move extremely quick. And the more powerful the computer, the quicker the object would move. Okay, but with this time.delta time, it actually limits all the computers to 1 set speed. And if you're ever going to move an object or translate an object, it's a really good idea to have delta time in there. Okay, I can't see any other reason why you wouldn't. Alright, so let's save this script at the moment, Control S. Jump back into the editor and let's just make sure that this script works. So let's create an empty cube. I'm going to set him to 0 on all 3 axes. And let's move him over so we can see him when we start the game. Alright, let's add the script, moving object. Bloop, onto the object, default 2, 2 and 1. Okay, that's fine. And let's hit start and hopefully he just moves up and keeps on going. There he goes. That's it. So what we need him to do now, we want him to go up 2 spaces, stop, and come back the other way. Okay, not necessarily stop, but just come back the other way. So the first thing we're going to have to do is we're going to use this direction variable here. So you can see initially we set it to 1 to move us upwards, And if it becomes -1, we're going to start moving down. So let me explain that quickly. Another way, if we wanted to move down, we could simply go vector3 dot down, and that would travel down in comparison to our world, okay, or just move straight down. Another way of expressing down would be a negative up. Okay, a negative up would just be simply down. All right, or we can simply times by direction. Now let's break this down a little bit. Let's go to a notepad and let me show you each one of these things one by one. I'm going to copy this all in the brackets and I'm going to explain this for a second, and let's break it down. So vector3 up is just simply up. Okay, times by the direction, by default it's 1, times by the default speed, which is 2, and times by delta time, let's just go for example's sake, it's 0.5. That's huge, but just for example's sake. Okay, so if we start breaking that down even further, up times 1 times, well, 2 times a half is 1. So essentially it becomes up times 1, which equals just plain up. Okay, so you break all that down and it just becomes we're moving upwards at just a regular speed. Okay, why the heck did I show you all that? Well, let's just say, for instance sake, direction changes to -1. I've said that -1 is going to move us down. This is how it works. So instead of 1 for direction, we're going to put -1, which becomes up times -1 times 1, which becomes this, which becomes a negative up. And what did we say a negative up was? It was down. And that's it. All right, so what we should have here is we should be able to control, as soon as direction becomes a -1, the object should start moving downwards instead of traveling upwards. And that's just a quick way for us to control which direction it's moving, up or down. All right. The next thing that we need to do is introduce this elapsed. Okay. We talked about elapsed being how much distance have we traveled? Have we traveled more than we wanted, or just the right amount? So we're going to check if we've traveled. Well, sorry, no. First, we're going to add the distance traveled, and that's easy. You just go elapsed plus equals, and that is this bit, speed times dot delta time. I'm going to copy and paste that one there. Okay, so that's how you calculate how much distance of travel. Now, the reason we don't include direction and vector up is that's just the direction we're moving. This is the actual amount that we've moved. Okay, the next line, we're going to check if we moved enough. In if. Okay, if statement time, if elapsed is greater than or equal to the distance, what are we going to do? We're going to turn around and come the other way. So direction starts at 1, we're moving up. If we want to turn around, we've got to go to -1. Really nice, simple way of doing that. Change direction and reset elapsed. You simply go direction times equals -1. And the reason that works is if you take 1 and you times it by -1, you get -1. You take -1 times it by -1, you get 1. Okay, so essentially what we're doing there is this line here, 21, swaps between 1 and -1, and that's perfect. That's all you need to do. And then we reset elapsed to 0. Okay, and hopefully this bit of code we just added from 14 to 24 will swap directions when we hit that distance value. So let's have a quick look, make sure it works. Press play. Perfect. Now, there's one little problem with this particular script. That is, okay, we're checking if the elapsed value is greater than or equal to the distance. Okay, and that's fine. That line is perfect. That's what we need. However, let's say, for instance sake, the amount of distance that we travel each frame, let's say that it starts at 0.55, and each time it adds that on. So the first value for elapsed is 0.55. When we add to the next one, it will be 1.1. Okay, you add another 5.55 to that, you end up with 1.65. Okay, and the next frame, when it actually becomes bigger than the value of distance, is 2.2. So what's the problem there? The biggest problem there is that we've got this 0.2 that all of a sudden is being lost. It's getting thrown away into the ether. Alright, so what we need to do is we need to take that point 2 and we need to fix it up, okay, with 2 lines of code. It's really, really easy. First thing we need to do is calculate how much of a difference there is. So that's quite simple. You just you minus the amount of distance we want, which is just 2. So 2.2 minus the 2 equals the discrepancy, equals how much it's over moved by. Okay, and what we're going to do is we're going to take that number, all right, and we're going to move back in the opposite direction slightly for it. Okay, and this may happen all the time, but it's a good idea to do it because that way it will end up in the exact same spot that it started, the exact. All right, and it won't overshoot and it won't eventually come off its hinges and just float off into the nowhere. So let's quickly calculate the over movement and move back. And this is pretty straightforward. If we go elapsed minus distance, okay, that's just done that for us. That's going to give us the point 2. We've then got to move in the opposite direction, which is pretty straightforward. Let's just transform dot translate, and pretty much the same as this code up here. So what we're going to do, I'm going to copy this code here, just the direction. I don't care about the speed because we have our own speed, which is elapsed. Okay, but this is traveling in the same direction. What we want to do is come back a little bit. So you want a negative direction. Okay, just to confuse you a little bit. Okay, so move back, that's going to be that line there. Okay, we're moving back a tiny bit. Alright, and that should fix any discrepancies which appear. I can almost guarantee you won't see any difference in my video right now. Alright, but if that cube runs for 5 hours, if we were using the original script, it would probably float off into nowhere. Whereas now, it can run for a lifetime and it will be in the exact same spot every single time. Okay, that's pretty much our movement script done, except now we're only going up or down. We want to go left and right as well, and we want to give the person making our level the option to move either way. And this is where I'm going to introduce what's called an enumeration. Okay, don't worry about what it is or what it looks like. We'll just use it. Okay, up the top, I'm going to type in enum, short for enumeration, and I'm going to call it movement, and I'm going to give it 2 values, horizontal, vertical. All right, you will not see any difference in the editor by writing that line in here. We have to add in a parameter, like always. Okay, and I'm going to call this one, notice how I'm using lowercase letters this time, instead of uppercase. The data type is going to be my uppercase one, and the default value is going to be movement vertical. Now, not to confuse you too far, let's pause. I'm going to jump into the editor. Let's have a look at that movement parameter, that enum. Look at that. So the enumeration, horizontal and vertical, comes from there. So the default value is vertical, okay, and we can either choose which one that we want to use. Okay, so enums are a great way to have a little drop-down list of different things that you want. So if you only want the user to be able to select between 2 different things, this is a great way, using an enum, to let them, or you can even have more. You can have, I think, up to 65,000 roughly, based on an integer. Okay, but right now, we've got 2 selections, horizontal and vertical, and we have to modify our code. So based on what they selected for the movement, it changes the direction that we move. Okay, so here we go. The first thing I'm going to do is I'm going to modify this code a little bit. I'm going to actually make another variable here, calculate the movement direction, and I'm going to use this variable all the time. I'm going to call it move_dir, and it's going to be a vector 3, just to confuse you a little bit more. All right, what this variable is going to do is we're going to calculate which direction we want to move to start with, and we're going to use this all the way through our script because it's about 3 spaces where we have to use this. And rather than having one big line like this, we're just going to use move direction. All right, so let's check the direction. If movement equals movement vertical, then you want to set move direction to vector 3 up times the direction. If you don't understand it, don't worry. It's a very simple bit of code that'll just work for us. Otherwise, the move direction is going to be vector 3 left times the direction. So basically what we're doing, we're checking what direction we're supposed to be moving. Are we going to be moving in a vertical direction, or are we going to be moving in a horizontal direction, so the left and the right? And the reason I've done that, the reason I've done this whole move direction thing, is I can copy this, and instead of vector 3 up times direction, I can just use move direction now. Okay? And the second reason I did it is because if we come down a little bit, we've got this vector 3 times direction again. I'm going to put it there as well, and put back the negative that I had before. Okay? So just changing those two lines and introducing the ones above, we now have a script which should be able to go up and down and left and right based on what we selected. So let's just make sure vertical still works. Up, down. Yep, he's good. Let's stop. Let's change it to horizontal. Perfect. Yeah, you probably don't want him moving through the other one, but that's transform.translate for you. And that's perfect. That's moving horizontally for us. And watch this. Could change it on the fly. So there you go. So that there is 100% done, our moving object script. Okay, I know that was a little bit complex, but let's move on to the next one, which is just short as and really, really fun. Okay, let's go into the chasing enemy one. So the idea of this script here is we're going to have an enemy that when we get within a certain distance, he's going to start chasing us. And if he touches us, he hurts us. Simple as that. Okay, 2 parameters up the top, same as last time. Speed. And we're going to set it to 1.8 to start with. So he's just a tiny bit slower than the default speed of the player. And we're also going to have a variable distance. Well, no, I'm not going to call it distance this time. Let's call it chase at. Okay. And we're going to go 5 units. Okay. The reason I call it chased at, because I like the idea of, you know, we're going to chase him at 5 yards or closer. All right. What we need to do, we're actually going to keep function start for this one. And what we need to do is, because we're always going to be checking how far away we are from the player, we need to easily remember what the player is. That might sound a weird concept. We're going to have a private parameter here. We're going to call it player, and it's going to be a game object. And the idea is, at the start of the game, so right here at start, we're going to find the player. So player equals game object find. The name is player, just like that. So find and remember the player. So right at the beginning of the game, we're going to look through every single object, or Unity's going to look through every object, find the one called player, and it's going to tell us what that object is. So no matter where the player moves to, we should be able to keep track of him because of that variable, because of that parameter, private one anyway. Okay, under function update, first thing we're going to do is we have to see how far away the player is every single frame. So what we're going to do is calculate the distance between the player and the enemy. And this one's actually quite easy. So var distance, okay, which is going to be a vector 3, equals vector 3 dot distance. And what you do with this one is see how it says distance accepts A and B, and what it does is it literally just calculates the difference between those two and gives it to you as a number. Okay, whoops, sorry. Get rid of that. It's just vector, sorry. Can't even read my own things. So var distance equals vector 3 distance, and we need to pass it 2 positions in the game. The first position is the one the enemy's in. Second one is where the player is. So to get the player position, we're going to use this parameter up here. Player.transform.position. So that's going to tell us how far away the enemy is from the player. Let's check how far we are, how close we are. So if the distance, okay, is less than or equal to the chase at distance, we're going to start chasing him. Chase the player. Okay, and there's 2 things we're going to do here. Okay, we are going to move, well no, there's only one thing we're going to do here. Originally I had 2, but let's simplify it just to 1. Okay, transform.translate, just like we always do. Okay, Now this is the toughie bit, okay? 2 brackets here, everyone. Player.transform.position. We need to calculate the difference again, unfortunately. Transform.position times the speed the enemy is going to move at, and then delta time comes in. As I said, whenever you translate, you need to include delta time. Alright, let's just check my brackets. I've got 1 open, 2 open, 1 closed, 2 closed. Perfect. Pretty much this is it. Let's test it out, okay? I'm going to take off the moving object to this guy. Actually, no. I'm going to keep him as a moving object. I'm going to make a brand spanker. Brand spanker, send to 0, 0, 0. Move him along. Let's drag the chase enemy script onto him. Okay, speed at 1.8, chase at 5. And we're also going to give him the green material, like we did originally. Okay, save. And hopefully when we get within 5 yards, he's going to chase us. Now there's the moving object. Yeah, yeah. He's chasing me. Okay, now I am going to do 2 things now. See how he's just hugging me a little bit too tightly. Okay, we don't want him to move up and down. So what we're going to do is we're going to introduce another private parameter. And what we're going to do is we're going to remember the original y value. So whatever y value that the enemy starts with, they're always going to keep for the moment. Starting y, just as a float. Alright. And we're going to set that here in start. So starting y equals transform.position.y. And then right here, underneath our translate, we're going to make sure he never moves from that y position. So he stops doing the whole floating upwards sort of thing. So transform.position.y equals starting y. Alright, I'll leave that there for a second so you can have a look. Jump back to the game. Now hopefully the enemy, we should be able to jump over him now, because he's not too friendly now. There we go. He's still chasing after me. And yes, I know that's a problem, but that's something we can fix at a later date. You can see the enemy still loves me, but he can't get me. There you go. Every single one of those scripts are done. We've got the moving object, we've got the speed up object, we've got the player. And quickly, if you'd like to make a cube or something that the player can't touch because it hurts them, all you have to do is use that tag. So let's put the red material on this one. This is going to be a bit of a, you're not allowed to touch. All you have to do, rather than adding a script or anything like that, you change the tag to hurt. Okay, and let's click on the player so we can watch his health down there. Let's move into that red object. Yeah. Doesn't seem to be working. There you go. 4, 3, 2, 1, and I'm dead. If you have a look in here, you died. So look, what you can do now is take all of what you've just in there. You've got the chasing enemy, you've got the speed up object, you've got a moving platform, you've got a hurting object, you've got the basic building blocks for making a whole side-scroller game. You can add as many levels as you want. You can add in different platforms. You can add in crazy enemies at the end. You can even add a hurt tag to moving platforms. Okay? And that just creates things that the player has to jump over or just obstacles that they have to get past. Okay? This just sets you up with all the basics that you need now to make this project what it really is. Don't worry about this object. I'm not going to fix it. Okay? That's just because the player's dead and the enemy's still trying to find him. Okay? That's what that error is producing there. We could fix it, but I'm not going to, because right now we're done. Good luck with everything, everybody. Hope you enjoy the tutorials. Hopefully I'll put some more scripting ones up soon. We'll do some different gameplay types, and this gets you started for your assessment. Good luck, everyone.